So what we're marking out here is going to be the extent of the container that will hold the near-infrared spectrograph. It's the next instrument that will be built for SALT. We're building it in Madison currently. That's under the leadership of Marcia Wolf, one of our scientists at UW-Madison. But it's going to be in a big box sitting here in this room on the ground floor of the Southern African Large Telescope building. So the idea of why to put the instrument here on the ground floor in an enclosure that will fit in this area inside the box we've drawn here is that the near-infrared spectrograph has to stay cold. And the reason it has to stay cold is because any kind of heat from the atmosphere, from the telescope, from the building will block out the signal that we're getting from some astronomical object. It will be fed by a really long fiber that will go from the telescope, the top of the telescope, all the way down the telescope support into the basement of the building and feed the spectrograph down here. That fiber is being assembled in Madison almost as we speak in Chamberlain Hall. We've got a rack up there that we're putting together that fiber. So the reason you do an infrared spectrograph is that the universe emits radiation at all wavelengths. The infrared is a particularly important part of the spectrum for two reasons. One, it allows us to peer a little bit deeper into the galaxy to see redder stars, but it also gives us a sense to see very distant objects whose light is redshifted from, say, the optical part of the spectrum into the infrared part of the spectrum. And that allows us to see galaxies much earlier in their evolution, because one of the really cool things about astronomy is that when we look farther away, we are seeing objects not as they look today, but as they looked a long time ago. And so if we're interested in the origins of galaxies, how they came together, we need to be able to look at very distant galaxies whose light is shifted into the infrared part of the spectrum.